Let us do some problems on conditional probability. Consider the experiment of throwing a dice. If a multiple of 3 comes up, throw the dice again. And if any other number comes up, toss a coin. Find the conditional probability of the event. The coin shows a tail given that at least one dice shows 3. To find out this conditional probability, first of all, let us write the sample space. What are the possible outcomes? All possible outcomes we need to first write. First of all, let's see how the experiment is being done. The question says, throwing a dice is the first stage. Once you throw a dice, there are 6 possibilities. But the experiment is not complete. Depending upon the result that might come up, the experiment is to be continued. If a multiple of 3 comes up, that is either 3 or 6 come, throw the dice again. In case the outcomes at the first stage of the experiment is either 3 or 6, then you need to throw the dice again. That means if you got 3, you will toss a dice. Again 1 to 6 numbers, either of them can happen. Or if it was 6 that happened, then also you would have thrown a dice once more, then 1 to 6 numbers. So the different outcomes could look like this. You got 6 in the beginning, then you got 1, 6, 1. 6 in the beginning with the 2 followed. 6, 3, 6, 4, 6, 5, 6, 6. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. This is one condition. If 3 comes up, you would do this. If any other number comes, toss a coin. That means in the first stage, if it was 1 that came up, you toss a coin. Coin has either head or tail. So that time there are 2 outcomes possible in case the first stage resulted in 1. That is 1H, 1T. Same with 2, 2H, 2T. Then 4, 4H, 4T, 5H, 5T. So these are the sample space elements. All possible outcomes are displayed here. Let's write it as a set. Sample space is a set. Set of all possible outcomes. They are 1H, 1T, 2H, 2T, 1H, 1T, 2H, 2T, 4H, 4T, 5H, 5T. Now the multiple 3. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6 here. Altogether there are 20 outcomes. Now notice one thing. These 20 outcomes are not equally likely to happen. What does it mean? Equally likely. Yes, there are 20 outcomes, but they are all not holding the chance of happening equally. It means, let's look at the experiment once more. In the first stage, when you toss a dice, all of these 6 numbers were equally likely to happen. Any of these numbers could have come up. So they all had equal probabilities out of 6. So 1 by 6, 1 by 6, 1 by 6, etc. This was the probability of each of them. But this one happening once has the chance 1 by 6. But at a later stage, this one's chance gets divided into either head or tail. So this 1/6 chance gets divided into half-half. So 1H gets half of 1 by 6 and 1T gets half of 1 by 6, which means 1H and 1T have the probabilities 1 by 12, 1 by 12. 1 by 2, half of 1 by 6. The other half of 1 by 6. Same here. This 1 by 6 gets divided into half-half. So half of 1 by 6 is 1 by 12. Half of 1 by 6 is another 1 by 12. So 2H, 2T also have the probability half-half. Same with 4H, 4T. 5H, 5T. All of these will have 1 by 12 chances. Whereas this number 3 also had the equal chance with others 1 by 6. But that 1 by 6 gets divided among these 6 outcomes. So each of them gets only 1/6 of this 1 by 6. That means probability of having 3 outcome will be 1 by 6 of 1 by 6, that is 1 by 36. Same with the next 1 by 36. 1/6 of 1 by 6. Same here. 1/6 of this 1 by 6 probability. So look, these 20 outcomes are not holding equal probabilities. 1 by 12 is bigger than 1 by 36. So this outcome 5t is more probable than happening this outcome. This is what we mean by saying these 20 outcomes are not equally likely. Now, let's go by the conditions given to us. The coin shows a tail. The coin shows a tail in many of them. Out of these 20, there are many. The coin shows a tail. Here it is 1t, then 2t, 4t, and 5t. These are the 4 outcomes which show a tail on the coin. So probability of A will be probability of 1t plus probability of 2t plus probability of 4t plus probability of 5t. But we already calculated the probability of 1t to be 1 by 12. Here also 1 by 12. So basically 1 by 12 plus 1 by 12 plus 1 by 12 plus 1 by 12 is 4 times 1 by 12. 4 times 1 by 12. That's the probability of A. Now second condition, at least one dice shows 3. This condition let me call it B. And one dice shows 3. Oh, these 6 of them show anyway 3. And also 6, 3. So one of the dice showing at least 1, 3 has these 7 outcomes. These 6 of them plus this 1. But each of them we calculated the probability is 1 by 36. So the total probability of these 7 outcomes will be 7 into 1 by 36. But we are expected to find the conditional probability. Conditional probability of the event A given event B. So what we need to find is probability of A given B. Let's go by the formula. Probability of A given B is probability of A intersection B upon probability of B. We have the probability of B 7 upon 36. But what do you mean by the probability of A intersection B? The probability of both of the events happening simultaneously. Common element. But look, event A had these 4 circled outcomes. Event B has these underlined outcomes. There is no common element. Event A has these 4 of them. Event B has these 6 of them. There is no single outcome that is coming common. Hence, the numerator probability of A intersection B is 0. No chance to happen both A and B. So, the conditional probability of A given B is 0 upon 7 by 36, that is 0.